Good morning students. Today we are learning one more optical experiment, and the aim of the experiment is to calculate the refractive index of the given glass slab using travelling microscope. So, the ray diagram is over here. This is the glass slab. This is the thickness of the glass slab given. Okay. So, we will place a cross mark on the bottom of the glass slab which acts as my object. So, this is the object. If you see the ray diagram, and observer sees through this, okay. So, ray diagram goes like this and it bends, and then it appears to, if you extend the light, it appears to come from this position. So, you can say that AO is the real depth, and your this distance acts as, that is your AO dash is acts as your apparent depth. And then through the microscope, we'll travelling microscope, we'll see or we'll focus the different position of the cross mark. We'll obtain the cross mark first over here R1 without the glass slab. Okay, the R1 reading is called as the real position, and we'll take the focus of the microscope on R2, which is called as the apparent position, and on the R3, that is on the top of what you see the glass slab, okay, that is the R3 reading of the microscope. So, you can say that this R3 minus R1 distance, okay, this reading distance of the microscope is called as my real depth, and this distance is called as the apparent depth. And to calculate the refractive index, we will use the known formula, that is real depth upon the apparent depth. So, the real depth is your R3 minus R1 and apparent depth is R3 minus R2. So, first we need to calculate what the least count of the travelling microscope. You see that the travelling microscope has the main scale as well as the vernier scale. On the main scale, how it is different is, now suppose that over here I have 10 and 11. So, within these two numbers there are 10 divisions over here on the main scale. So, therefore, the smallest count on the main scale will be what? 1 divided by 20. That means after the 10, the smallest count will be 10.05, then 10.1, then 10.15. Okay, this is how it goes on the main scale. Apart from the other pencil scale where it is 10.1, 10.2, 10.3. This is how we read in other scales. And the total division on the vernier scale of the microscope is 50. So, 1 divided by 20 divided by 50 gives me what? 0.001 centimeter. So, this is the least count of the travelling microscope. Okay. So, let us have the observation table. So, in the observation table we have what? First is, we will take the reading of the microscope when the microscope is focused on what? Cross mark without the glass slab, that is this position. So, it will have the same thing, main scale reading, coinciding division and vernier scale reading. How do we obtain the vernier scale reading? By multiplying the coinciding division and the least count, we obtain the vernier scale reading and we obtain the total reading. Total reading will be your main scale reading plus the vernier scale reading. That will be your R1 reading over here, focused over here. And second, we will place the glass slab on the top of the cross mark, and the object appears to be raised over here. So, the object appears to be here. So, we will focus the microscope there, that will be my second reading, that is for the R2. Again the same, main scale reading, coinciding division, vernier scale reading, multiplied the least count and the coinciding division, we obtain the total reading by MSR plus the VSR. Now, the third reading will be, we will place the cross mark on the top of the glass slab and we will get what? The focus of the microscope on that cross mark. Again the reading will be same, main scale reading, coinciding division, least vernier scale reading and the total reading. Okay, total reading is main scale plus the your vernier scale reading. Now, I will tell you how to read the main scale first of all, how to read the main scale and how to read the vernier scale. See, you have a main scale over here and you have a vernier scale attached to that. So, in the vernier scale there are 50 divisions, but in the 0 reading, okay, 0 scale of the vernier scale, okay, over there is an arrow. That arrow points some line in the main scale. So that reading will be your main scale reading. For example, in the diagram over here, I have shown that my 0 is pointing out toward this line. So you can say that this is 3.05 and this is 3.1. So in this diagram, my main scale reading is 3.1 centimeter. Okay, and what do you mean by coinciding division? Coinciding division means, okay, in vernier scale there are totally 50 divisions. Out of this 50 divisions, one line of the vernier scale will be in complete alignment with what? Any line of the main scale line. That is called as your coinciding division, which gives me the vernier scale reading by multiplying this coinciding division to the least count. Okay, so that gives me a vernier scale reading. Now let's see how to take the observation with our travelling microscope. Yeah, this is our travelling microscope. Okay, now first I'll explain you about the instrument. The travelling microscope mainly has the main scale. This is the main scale, and over here there is the vernier scale. Remember, the main scale has got 20 divisions in between the each centimeter. Okay, so the least count is 1 divided by 20 on the main scale, and there are 50 divisions on the vernier scale. So the least count of this travelling microscope becomes 1 by 20 divided by total this 50 divisions, so it becomes 0.001 centimeter. Okay, so this is the scaling about. Why this is called as travelling microscope? Because for a practical purpose we can change the microscope along horizontal, as well as depending on the need we can change it along what? The vertical axis. So therefore this is called as travelling microscope. The microscope over here is this one, and this is your compound microscope. Over here it has the objective lens, and over here the eyepiece lens, and we always see through this eyepiece lens, and using this terminal we can change what? The focus of the microscope. We need to calculate the refractive index of the glass slab using our instrument, travelling microscope. So this is the glass slab, and for that what we need to do is we need one small paper, and on that I'll make certain cross marks which will act as my object. And as the scales are very small, so it is not clear to read it. Okay, so we use this magnifying glass to read the scales. So first I'll put the object over here, and then fix this height of this compound microscope at certain height, and then using this terminal I'll focus the microscope, travelling microscope, on the object. So this is your objective lens and this is the object. So now using this terminal I can easily focus See, you have to keep rotating this until you get the sharp image of that cross mark. Now I have got the sharp image of the cross mark, and now you can read the main scale and the vernier scale reading. So when I do this, right now I found out, using the magnifying glass you have to read it on the scale. So I found out that the main scale reading is it is 2.51, and this is on the main scale, and on the vernier scale we need to find out the coinciding division. I found out that the coinciding division is it is 40. That means on the vernier scale the 40th line is coming exactly on line of any division on any line of the main scale. So that means coinciding division. So this coinciding division has to be multiplied with the least count, that is 0.001. So it becomes 0.04 and then total reading is mean scale reading plus vernier scale reading. So what was my main scale reading? It was 2.51 and that is the 40. So 2.550 becomes my first reading. Now the second reading is obtained by placing this glass slab on the top of what? The cross mark. And but remember, okay, whenever we take the readings, we have to keep our this distance fixed. That means the distance between what? The object and objective, this is fixed. And now I will repeat, keeping it on the glass slab on the cross mark, and this now I am not allowed to move because this was fixed over here already, okay, for the R1 reading, first reading. So I have to move this over here to obtain the second focus. So I will move this, and again I will find out what? The position when the sharp image of crosswire is obtained. See, now I have obtained it, and remember, for this purpose I have moved this part, this screw, okay, this is fixed. Remember that this has to be fixed throughout. So now using the magnifying glass I will see the reading, okay. So using the microscope of magnifying glass, the reading, the main scale reading I have found out, it is 3.2 and the coinciding division is 34. So this coinciding division is multiplied by the least count and then it is added with what? Main scale. So that will give me what? The second reading. And now the third reading is obtained by placing what? This cross mark on the top of what? The glass slab. Again remember, this has to be fixed. I am allowed to move only this screw. So I will raise the microscope until what? I obtain the same sharp image of the cross mark. So here I have obtained the sharp image of the cross mark. Again I will take the reading. The main scale reading is again 4, it is 4.35. Remember, main scale reading is where the zero arrow of vernier scale pointing out on the main scale, that is your main scale reading. So right now main scale reading is 4.35 and on the vernier scale the coinciding division is again 40. So this is multiplied with the least count and added to the main scale reading. So this gives me what? The reading R3. So your first process is to calculate R1, R2 and R3, the three readings on the travelling microscope. The first reading R1 is the microscope focused on the cross mark. The R2 reading is microscope focused on the cross mark with what? Glass slab. And R3 reading is when the microscope is focused on a cross mark which is kept on the top of the glass slab. So this is your R3. And when we obtain all this set of R1, R2 and R3, remember this has to be kept constant. So how can we calculate the refractive index from this observations? Remember, refractive index is your real depth upon the apparent depth. The real depth is your R3 minus R1 and apparent depth is R3 minus R2. So now putting the value of R3, R2 and R1, I can calculate the refractive index of this glass slab. Remember, the standard value of the pure glass refractive index is 1.5, but with my calculations, okay, I should be getting the refractive index nearly to 1.5, not exact 1.5. Okay, now again how to repeat the experiment? You set this cross mark over here again and put the microscope, okay, compound microscope at some other height. Remember, last time we have put at some other height, Okay, now I'll put it at some other height, and again remember, now I'm allowed to use this terminal. So using this terminal, I'll be focusing what the cross mark with the help of microscope, but remember this is only for R1 I am allowed to move. When I am taking R2 and R3, this has to be fixed, remember that. So again I have put what is a microscope at some other height, and then I'll take again I'll focus until I'll get the sharp image of this cross mark. Now see, again I have got the sharp image of the cross mark, but now my main scale reading has already changed. Now roughly I'll tell you my main scale reading is 4.55 and the coinciding division is 19. So see over here, now the second set of readings R1 is already changed. So again I'll put over here, this will be my R2 reading. For that it will be fixed. I'll move this screw and get the sharp image. See, I got the sharp image again. I'll take the reading over here, okay, and once again I'll keep it over here and again move this part and get the sharp image, and this is my R3 readings. So this way you have to take R1, R2, R3, R1, R2, R3, R1, R2, R3 3 times, and from this set of 3 R1, R2, R3 readings you will be calculating what 3 readings of refractive index, and you can take the mean of all the refractive index. That will be your answer for this experiment. Yeah. As I have shown you how to take the observations in the microscope, okay, so I have noted down the readings. Now what I have found out is that when I focus the microscope on the cross mark, okay, without the glass slab, my main scale reading was 2.51, and that time remember the coinciding division was 40. So this is multiplied with the least count 0.001, I got 0.040 as my Vernier scale reading, and this Vernier scale reading should be added to the main scale reading, and that will give me what the total reading for this observation, that is 2.550. So this reading is my R1 reading. Now once again I'll place the glass slab on the top of what is the cross mark, and I got the readings. I have noted out that also. That time I got the main scale was 3.2, okay, Vernier scale coinciding was 34. This is multiplied by the least count, I got 0.034, and added to what is main scale and the Vernier scale, main scale and Vernier scale, I got 3.234. Then this reading is my R2 reading when it was focused with the glass slab. Now third was when I placed the cross mark on the top of the glass slab, and I got the focus of the microscope over there. So that time I got main scale reading is 4.35 and coinciding division was 40, and the Vernier scale is multiplied this with the least count, I got 0.040, and total reading I got 4.390 by adding the main scale and the Vernier scale. Now when I got the R1, R2, R3, then you have to change the height of the microscope, and you can repeat for what R1, R2, R3 again, and again change it the height, okay, and you got R1, R2, R3. So this way we have to take 3 sets of reading R1, R2, R3, R1, R2, R3 and R1, R2, R3. Now with this observations I have calculated my refractive index. So it was R3 minus R1, this is your real depth, and R3 minus R2, this is your apparent depth. With this data, okay, with this observation I got the calculation done for the refractive index. Right now for this observation I am getting refractive index as 1.59, and you know that the standard value is 1.5, okay. So you can repeat the experiments and you will get the another mu, and then finally take the 3 mu and take the mean of all the mu, that is, and average should come nearly to your 1.5. Yeah, thank you.